Hello. Today we're going to have a lesson on elimination. So it's much like substitution. So substitution, we were, again, trying to find the solution to a linear system. We were trying to find a value for x and y that worked for both equations. So we're going to have an equation here that I will write down. So it's going to be 3x plus 2y equals 17. And 7x minus 2y equals 33. So that's the linear system we're going to try to solve. And right away we can see there's a problem. Okay, so actually stop writing. I'm going to write something on a separate piece of paper. So if I had 3x plus 2y equals 17, 7x minus 2y equals 33. And let's say I rearranged number 1, so I'd get 2y equals 17 minus 3x, y equals 17 over 2 minus 3 over 2x. And that's looking pretty terrible, because then when we sub it in, we would get 7x minus 2 times 17 over 2 minus 3 over 2x. Well, not as bad as it could be, but it's still a little bit yucky. So we're going to be learning a different way of doing it. This would work, but we're going to be doing a different technique. So what we're going to be, let's go back to our original so you can start writing again if you're writing these notes down. So I'm going to do my usual thing where I label these equations. And what I'm going to do is I'm going to actually add up these equations. I'm going to add it up kind of in vertical columns. So I'm going to add up this and add up this and add up this. And 3x plus 7x, 3 plus 7 is 10x. And then 2 plus minus 2 is what? 2 plus minus 2 is actually 0. Plus 0y, and then 17 plus 33 is 50. So what's happened here is important. 0y, what we've done is the y variable is 0. There's 0 times y is just 0. This has been eliminated. So it's gone. So we don't have y's anymore. So what happens now is the equation becomes 10x equals 50. And then we could go divide both sides by 10. And we could get x equals 5. And then we kind of take a step from substitution, where we're going to sub x equals 5. And like, it doesn't actually matter which equation you sub it into. We could do the first or the second. I'll do the first because I don't have a good reason. So into equation 1. So it's going to be 3 times 5 plus 2y equals 17. Why is it 5? It's 5 because x was 5. I should have written out the equation first. I forgot. Equals 17. Bring the 15 over to the other side. So 17 minus 15. 2y equals 2. Y equals 1. And so that we have is therefore the solution to the linear system is x equals 5, y equals 1. There we go. That's not us. I'm not sure why it's beeping. So that's an example of elimination. Not too hard, right? So now we have example 2. Example 2 is going to be 4x plus 3y equals 34. 5x minus 2y equals 31. And I'm going to try to add these up. So let's add these guys up. So 4 plus 5 equals 9x. And 3 plus negative 2 is what? So 3 plus negative 2 is 1. So plus, you could write it as 1y or just y. And that plus that is going to be 65. Now the problem here, on the previous example, we eliminated a variable. But here, it's not eliminated. All right? Not eliminated. Sad face. With a tear. Or 2 tears. Because it's very sad. It was not eliminated. Elimination didn't work. We give up and we go home. Well, that's not totally true because, as you can see, this video is longer than 5 minutes and 43 seconds. So we're going to do something else. We have a new plan. So we're going to take the same thing. So we're going to go 4x plus 3y equals 34. And then 5x minus 2y equals 31. So the exact same thing. I'm going to label these as 1 and label these as 2. Now what I want to do is I want to make it so that I can eliminate a variable. So I'm actually going to multiply these equations. All right, so what I'm going to do is I'm going to take equation 1. That's off the screen, isn't it? I'm going to take equation 1. I'm going to multiply it by 2. And we don't know why I'm multiplying by 2, but for now, you'll see what happens. I'm multiplying it by 2. And then equation 2, I'm going to multiply it by 3. So I'm going to multiply the first equation by 2. I'm going to multiply the second equation by 3. And so what I end up getting when I do that is I get... when I say multiply by 2, means I'm going to multiply this by 2, and this by 2, and this by 2. I'm going to multiply this by 3, and this by 3, and this by 3. So 4 times 2 is going to be 8x. 3 times 2 is going to be 6y. And 34 times 2 is going to be 68. Now here I'm multiplying everything by 3, so 5 times 3 is 15x. Negative 2 times 3 is negative 6y. And 31 times 3, if you do it in your calculator, is 93. And what we notice now is that with the y's, you have the same number. Remember, the the mathematical word for that is the coefficient. The coefficient of the y here is plus 6, and there it's negative 6. And if one's positive and one's negative, when we add it up, it's going to give us, in fact, the 0 that we crave. So 8 plus 15 is going to be 23x. 6 plus minus 6 is going to be eliminated 0. And 68 plus 93, I don't actually feel like doing it in my head. Well, it's going to be 7 less than 68, right? So probably 161. 93 plus 68 is 161. 161. So then we have, continue, 23x equals 161. Divide both sides by 23. I actually did that on the calculator. And we get that x equals 7. So then we sub x equals 7 into, and we could sub it into any of these. We could sub it to this one, or this one, or this one, or this one. I usually try to do it in one of the originals, but there's no reason why you have to. So equation 1 is 4x plus 3y equals 34. 4 times 7 plus 3y equals 34. So 28 plus 3y equals 34. 3y is 34 minus 28. 3y equals 6, so y equals 2, which means, therefore, the solution to the linear system is x equals 7 and y equals 2. And that's the example I have over there. So I'm going to stop this video right here, and then we'll continue with the next one after.